In our past video, I give you a demo of a sample program that we run in Dev C++. Now here we have the general form of a C program. From this global declaration up to that. Now F1, F2, up to Fn, these are called user-defined functions, meaning they are not built-in functions. Okay, these are not built-in functions. It is the programmer that defined these functions. And so, since these are user-defined functions and not built-in, then the declaration or the definition of such functions with the name F1, F2, up to Fn should be included in the program. So again, we call this the function definition or declaration. So this contains what are to be executed, what statements or instructions are to be executed when this function is called. And for function F2, these are the set of instructions or statements to be executed when F2 function is called. And also for Fn, these are the instructions or statements to be executed when the function Fn is called. Now notice that for each function, whether it's a user-defined function or the main function, which is where the execution of the program starts, this is the main function where program execution starts. So the statements and the instructions inside the main function are the ones executed when you run the program. F1, F2 to Fn are executed only when they are called maybe from the main function or called by a function that is called by main function. Say for example, from main function we call F1. And so F1 is executed, all the statements in here. And say one of the statements in here is to call F2, then that's the time the statements or instructions for function F2 are executed. So that's the idea of function call. But we will go into details of that when we reach that particular topic on functions. Now notice that for every function, whether it's the main function or a user-defined function like F1, F2, or Fn, the body of the function is marked by the open curly and the closed curly. This is where the body of the main function starts, and this is the end, the beginning delimiter and the end delimiter. Or you could also call this the function block. The function block marked by the open curly and the closed curly, or you could also call this the body of the function. Now, for each function, notice that there are two main parts: the local variable or variables declaration. It's called local because it is inside a function. A variable is global when it is declared outside of a function, and it is declared in here on top among the global declarations. So take note, on top of the program are the global declarations, and this consists of header declaration, the one like this in our previous demo. Okay, so that's an example of a header declaration, a constant declaration, which we're going to discuss soon, type declaration, type of a variable or data structure, variable declaration. This is what we refer to as the global variable declaration. So when a variable is declared outside of a function and it is among the global declarations on top, then we call that variable a global variable. If it is declared inside a function, whether it's the main function or a user-defined function like F1, F2, Fn, we call this local variables. And soon we will discuss the difference between global variable and local variable. So again, The two main parts of any function is the local variable declaration. The second is the statement sequence, the set of instructions to be executed. Like for example, in our previous program, the one that adds two input integers and output the sum, we say number include stdio.h. This is the header file where the definition of built-in functions printf and scanf are defined. And so since we are going to use the built-in functions printf to display something on the screen and scanf to get input from the keyboard, then you are going to declare this on top as a global declaration. The header declaration is an example of a global declaration. So this is our header declaration, one of the global declaration in our program. And then next we would say void main and then open curly and close curly. Okay, this is our main function where again it is the starting point of the program's execution. What do we need to have first inside our main function? The local variable declaration. Say we are going to add two integers, right? So we're going to declare two or three variables. The third variable is to hold the sum. So we would say int x comma y comma z, and then we would say printf input to integers. So whatever is inside these double quotations, that is exactly what will be displayed on the screen. So that's printf to display on the screen, and scanf is to get input from the keyboard. So what are the types of the two inputs? They are integers, and so we would say %d comma or space. You can separate the two integers by a space or a comma. So the first integer we would like to input is for variable x, this one, and the next for variable y. Okay. Now, as I have mentioned already before, the ampersand is a prefix to the variable because that ampersand means memory address. Ampersand x means memory. This is memory address. It is a unary operator that returns the memory address of the variable x in the RAM. So we're like telling the computer, instructing the computer to get an integer value from the keyboard user input and store or save that value, integer value, in the memory address of x. So there must be that what we call as ampersand. Okay, this is an ampersand symbol, and it is a unary operator to mean memory address. That is read as memory address of x. And this is also memory address of variable y. And then we would say z is equal to x plus y. Okay, since we have already the value of x and y from the previous scanf, then we add the two and put the result in variable z. And then the last statement would be to display the sum. So you could say the sum of %d and %d is %d. And then you output for this conversion specification x, for the second is y, and for the third you output z. Okay, so this is the last statement, the printf, and after that comes the close curly. So the close curly comes after the printf. So again, this part here is this one, local variables, which are three variables, x, y, z. And from that printf first up to the last printf, that is our statement sequence, or the set of instructions to be executed when the program is run. Let's say we're going to create a program to compute the area of a circle. So from our previous discussion, every program needs to include the stdio.h because that is the header file in the C library that contains the definitions or declarations of built-in functions for the standard input and output. Okay, that's why it's called stdio. std is standard and I is input, O is output. So stdio is the standard input and output header file. The standard output function is printf, right? So we say printf. This is what we call a multi-line comment delimiter. Multi-line because from that line up to this line, how many are those lines? From line 11 up to line 23, all of those lines highlighted by dark blue are comments. They are not part of the executable program. They are simply comments, description of what the program is about. And we also call this a comment, but this is a single line comment. Single line comment. And the single line comment delimiter is this one, 2 forward slash without space in between. So from that single line comment delimiter up to the end of that line, the line highlighted by the dark blue color, that's a comment. So this is also a single line comment. There's a single line comment, and this is multiple line comment. Let's say we want to display the statement or the sentence, this program is to compute the area of a circle. And then we will prompt the user to input the radius, right? We would say input the radius of a circle. Then after that, we would use scanf to get the user's input. The local variables, by the way, that we need to use are radius and area, right? So let's say we use the data type float. You could also use double. Float and double are real numbers type. They are both real numbers. Float is 4 bytes in the RAM allocation and double is 8 bytes allocation. So double is bigger. It could be used for bigger real numbers. So we say double radius, comma, area. So these are the two variables. We could also separate them, but since they are of the same type, you can just declare them in one line. Instead of this, two lines declared separately, since they are of same data type, you could just declare them in just one line to save space and to simplify the variable declaration. The conversion specification for double is %lf, then we say comma, ampersand radius to mean store that input double type value in the memory address of variable radius. And after that is our formula. Area of the circle is equal to what? Pi r square, right? Pi is 3.1416. Then multiplication times radius and terminator semicolon. And then finally a printf to display the area. We would say the area of a circle with radius. We use a conversion specs again. %lf radius. This is to display the radius, and that is LF because radius is double type. LF is the conversion specification for double type. Then we say is, and then we want to display the area. So %lf again because the area is double. And this is comma output. For this one, we output the radius. And for this one, we output the area. Then save it. Okay, obviously that is not saved yet as indicated by the asterisk. So we save it, and also the default file name is untitled. That indicates that you have not saved it yet. So we save this and say we use the name circle. And I would recommend that you use the file name extension .c instead of CPP, because the compiler is strict when compiling a .cpp program file, but it is not strict when compiling a .c program file. So I would recommend that you use .c, not .cpp, so that you will avoid having some errors or warnings that are not necessary. Okay, so let's save this. And what are the two things to do when executing a program? First, you compile it by clicking this button. Okay, and second, you run it. Once the compilation is successful, no errors, then you can run it by clicking this button. So let's try to compile. Okay, this is the compilation results. And there are no errors, zero warnings, no warnings, zero. And then we have successfully generated the output file name, which is the true executable code, which is circle.exe. Okay, this is now the zeros and ones true executable code. And the output size is 128.6 kilobytes, KB, and the compilation time is about 0.44 seconds. So since the compilation is successful, we can now run our program. Click this one. And there we have our output window. So what's in our output window? Of course, the printf, which says this program is to compute the area of a circle, right? And then period, and then next to display is input the radius of a circle. And the blinking cursor is our scanf in action. It means that the computer is waiting for the user to input the value of radius. So say for example, we input 2 and press enter. So area is computed, and then next output, and the last statement is printf the area of a circle with radius. And what appears here is the value of radius, that is 2.000. By default, we have trailing zeros, which is annoying to look at, right? So later we will try to simplify that one and learn how to do that. And after the radius value, which is 2.000, you have the is, and then the value here is the value of area, which is 12.56, right? And just ignore the statements below the broken line, because this is simply added by the devseek, a description of the execution result. So that's just an internal information. So let's say we want these two lines to appear on two separate lines on the screen. Okay, so we could put in here escape sequence \n, the new line character. \n is called the new line character. If you have that inside the printf, what will happen is that after this is displayed, this program is to compute the area of a circle, the cursor moves to the next line, and so succeeding printf output will be on the next line. So let's try that. Since we revised the code, we need to save it and recompile it, okay, so that our revision will take effect. Okay, compilation is successful, so we run it. And so that is the effect of our new line character. Previously, this second line appears on the same line here, right? Before. But now that we have the \n, the next printf, the next sentence to be output on the screen is on the second line. And then the scanf, okay, indicated by the blinking cursor. Say we input 3, our radius this time is 3. And then the radius is 3.00 is, that is 28 is 3 times 3, 9 times 3.14, 16. That's 28.27. Okay. Now, how do we remove the trailing zeros? We could put in here point, say we want one decimal place only, or say one decimal place for the radius. Okay. So the 0.1 there means we want to display the value of the real number, the double type number, in one decimal place only for radius. And say for area, we want to display two decimal places. So we put there 0.2 LF. So again, the 0.2 is to be placed between the percent and the LF conversion specs. Okay, so we save this and recompile. It's successful, so we run again. Say we input 2. So the output now is 2.0, right? So one decimal place only for the radius and two decimal places for area. How do we declare a constant? We can declare a constant. Remember from our previous slide, a constant declaration is among the global declaration. So how is it declared? We say number define, say pi is the constant name and the constant value of pi is 3.1416. And there is no semicolon for the constant declaration. So instead of using that value there, we could just use the constant name pi, because the constant name pi represents the constant value 3.1416. So we use pi instead of that value. And then we save it because we made some revision and recompile it. It is successful, so we can run it. Say we input 3. And there you have the area, okay? So this is a constant declaration. So pi is not a variable, it is a constant. What's the difference between a constant like pi and variable radius or variable area? These are variables because variables can have different values. That's why it's called variable. The value may change. Okay, just like radius a while ago is 2 and then later it's 3. And so area is, when radius is 2, area is 12.57. When radius is 3, it is 28 point something. So for variables, these are like containers having that can be assigned different values at any time. While for constant, this is like a container with a fixed value all throughout the running session of the program. So only one value for constant, and it cannot be changed. You cannot say here in your program you want to change pi. You would say pi is equal to 4.12. You cannot do that. That's incorrect to assign a new value to pi because pi is not a variable. Pi is a constant. Now, last time we have discussed about programming errors, and the 3 kinds of programming errors are, what are those? First is the syntax error. This is grammatical rule error or error in the grammar of the language. Second is runtime error. And the third is logical error. An example of a syntax error is, say for example, we remove this one, the terminator. We are supposed to put a semicolon there. So say we save it and then recompile. So there we have the error message. So what our dev C++ IDE will do is when you compile it, the compiler will report the error. And what is that about? Expected semicolon before printf, and that is in line number 10. This is line number 10, 9, 10. That is the line number 10. What is the error here? Expected semicolon before printf. Before this printf, there must be a semicolon. So before this is this line, right? So there must be a semicolon there. And then save it and then recompile. Okay, so the compiler encounters no more errors, and so there are no errors being reported by the compiler. And we can run it again. 3. Okay, so that's the area. Press enter to exit the output window.